This is pre-calculus, notes on section 7.3, graphs of cosine. Okay. Cosine is a periodic function, and its period is 2 pi. Cosine is a phase shift of sine. So what you're about to see with the cosine graph is very similar to what we already did with the sine graph. In just 1 second, what I'm going to do is I'm going to switch over to a blank screen, and I'm going to give you some strategies on how to graph this from scratch with a limited amount of precision. So here we go, new screen. And the first thing I want to do is I'm going to set up my axes. Make this wide. Make it as wide as your notebook is so that you've got enough room to show a large domain, because we're going to graph this from negative 4 pi to pi. So over here on the left I've got negative 4 pi, and on the right I've got positive 4 pi. This is the exact same thing that we went through when we did sine. And then I'm going to break up the interval between 0 and 4 pi. I'm going to break that in half. Break that in half again. All right, so now I've got 1, 2, 3, 4 pi. And now we're going to do the halfway intervals in between that. So we've got pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So again, those are odd multiples of pi over 2. And here I've got the mirror image on the left. Okay. And again, on my y-axis, I'm going to label from -1 to +1. Let's go back and take a look at this cosine graph again real quickly. This is the book version. Theirs is going to be a lot prettier than mine is. Okay, but what are the important things? And the most important things to base the graph on are where the zeros are happening, where the maximums are happening, where the minimums are happening. So let's take a look at the zeros first of all. My zeros for cosine occur at every odd multiple of pi over 2. Okay, that's where the zeros are. All right, so pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Those are odd multiples of pi over 2. That's where all the zeros are for cosine. The maximums are happening at 1, 2 pi, 4 pi, etc. So let's put the maximums in. The largest that cosine can be is 1. So cosine of 0 is 1. Cosine of 2 pi is 1. Cosine of 4 pi is 1. Cosine of -2 pi is 1. Cosine of -4 pi is 1. And then all of the minimums are occurring at pi, 3 pi, 5 pi, etc. Okay, all the odd multiples of pi. So let's put those in a graph. So I've got minimum at pi. I've got a minimum at 3 pi. I've got a minimum at -pi, and I've got a minimum at -3 pi. All right, so that is, that's what you need for the graph. This is a rough sketch. Okay, so you are going to have to be able to sketch that graph from scratch. Here's what one cycle of cosine looks like. This is happening between 0 and over here is 2 pi. Okay, one cycle occurs over a period, and the period is 2 pi. All right, state the domain and the range. And again, just like with sine, right, the domain is all real numbers. You can find the cosine of any angle from negative infinity to positive infinity. And just like with sine, the range is going to be all of the y's between -1 and +1, okay? There is no angle that can give you a cosine of anything larger than 1. There is no angle that can give you a cosine of anything smaller than -1. There's your range. All right, this is a typical test question. Okay, on a typical test question, just from scratch, you're going to have to be able to graph cosine on any given interval. So the interval that they're asking for here is between pi and 7 pi over 2. So they're asking for no negative angle, so I'm really only concerned about positive. That's why I'm going to put my y-axis all the way on the left. Okay. 7 pi over 2 is just a tad smaller than 6 pi, I think. No, 4 pi. All right. 7 pi over 2 is just a tad smaller than 4 pi. So I'm going to just set up my intervals by first setting up my axes from 0 to 4 pi. All right, and again, I'm splitting them in half. I'm splitting them in half again. All right, and now I'm just going to create some dotted vertical lines on the interval they're asking me for. So what they want is a graph between pi and 7 pi over 2. All right, so if you see this question on a test, part of what the grader, that's me, is looking for is, do you even know what that interval between pi and 7 pi over 2 looks like? So set those intervals up. All right, now, again, cosine has zeros at every odd multiple of pi over 2. So I've got a 0 here at 3 pi over 2 and at 5 pi over 2. Cosine has a maximum at 0 and at 2 pi. All right, so here's 1. Oops. Okay, down here's -1. All right, so I've got a maximum at 2 pi and again at 4 pi, but that's outside of the interval that I'm graphing. All right, I've got minimums at pi and at 3 pi. Okay, so now I'm just going to connect the dots in a smooth curve. Oh, what am I doing at 7 pi over 2? At 7 pi over 2, we've got a 0. There we go. All right, so that's it. Typical test question. Moving on. State all of the values of t for which cosine of t equals 1. Okay, when you're asked this question, nobody's going to give you a graph. Okay, so part of what you're going to have to do is to be able to draw a rough sketch of the graph. All right, I've already drawn a rough sketch of the graph. There it is. And let me see if I can double screen this. Okay, there it is. So on the left, you see a rough sketch of the graph of cosine. Over here on the right is the question. State all of the values. Oops. State all of the values of t for which cosine of t equals 1. We're not asking for a few of the values. We're asking for all of them. And there are infinitely many. So we're going to use an arithmetic sequence to express that. And let's get started first and just taking a look at what some of those values are. Okay, let me get my highlighter out. So cosine of t equals 1 right here. What is that? That's -4 pi, -2 pi, 0, 2 pi, 4 pi. All right. negative 4 pi, negative 2 pi, 0, 2 pi, 4 pi. Okay, so what I'm going to do is I'm going to take this one closest to the origin. Okay, I'm going to take that 0. And that's going to be the first term in my arithmetic sequence. I'm going to call that my u sub 1. So u sub 1 equals 0. Okay, and then the common difference between each of those is 2 pi. Okay, so to write the arithmetic sequence, I'm going to say 0 plus and minus all multiples of 2 pi. In other words, another way to say that is 2 pi k, where k is an integer. And then, of course, 0 plus anything is itself. So in simplest form, I've got positive and negative 2 pi k. That is the answer. State all values for which for which cosine of t equals 1. All right, I am going to skip 0 because I've already got an 11-minute long video. I'm going to go to, let's see right there. I'm going to go to this one because this one's harder, okay? And here I've got state all the values for t for which cosine t is negative 1/2. Let me find them on my graph. I'm going to use this pink, okay, pink highlighter. Yep. Yeah, where'd you go? Pink highlighter, okay? So we've got negative 1/2. That would be here on the graph. Okay? And what happens, that happens twice for every cycle, and they're not evenly dispersed. So we have to take a look at where is cosine negative. Okay? So if I just draw my quadrants over here, I know that cosine is negative in quadrants 2 and 3, okay? So I need to find the reference angle, all right? So if I look on my trig card for where is cosine equal to 1/2, I find that the reference angle is pi over 3. So I've got pi over 3 here. I've got pi over 3 here, all right? So my first theta, okay, is going to be pi subtract pi over 3. Okay, so I've got my first u1 is 2 pi over 3. Okay, and then every cycle of 2 pi after that, I've got another value where cosine of t equals negative 1/2. So my first answer is going to be 2 pi over 3 plus or minus 2 pi k. That's half of my answer. All right. Now, all right, what I just found is, I just found this one. So now I want to find this one, okay? That is the one that is in quadrant 3. All right, and that angle it has the same reference angle, pi over 3, but it's pi plus pi over 3. Pi, oops. Technology problems. Pi plus, computer's not working with me, pi plus pi over 3, which is equal to, that's a 3 down there, which is equal to 4 pi over 3. I'm going to go back to full screen on this so I can finish this up. All right, new page. All right, so what I've got here is my u sub 1 is 4 pi over 3. And then every full cycle, which has a period of 2 pi, I've got another one. So I've got 4 pi over 3 plus and minus 2 pi k. That's my second answer. So again, my final two answers are 2 pi over 3 plus or minus 2 pi k, and 4 pi over 3 plus or minus 2 pi k. All right, it's a nice 15-minute long video for you.